else agree that it's roughly 12 o'clock? No major complaints if I start now? No? All right, good. All right, let me introduce this thing. Well, actually, let me introduce myself first, because that would be polite. So my name is Steve, and I work for Microsoft on this team that makes Azure mobile services. I'm a developer on that team, and mainly my job has been to make the web-based management interface that you're going to see quite a lot of during this talk. But I've also worked on a few other bits of the system, so if it breaks, it's probably my fault, and I can be doubly embarrassed about it. But let me just introduce this whole product as well and talk about what problem it solves. So let's do a little bit of pretending and think about a scenario that you might be in as a developer. And to help you understand that, I've got a series of photos that might illustrate it. So here is you. Now, this is not actually a photo of you. I reconstructed this artificially using Lego. But it represents you working on your massive old computer on some kind of boring enterprise reports workflow management solution thing. Some boring thing like that. And you're thinking, oh, it's so boring. How am I going to get through the day? And you think, oh, well, I'll just make some more coffee. And you reach out for the coffee pot, and then you realize, hey, this is not a normal coffee pot. This is some kind of magic lamp. And when you touch it, a genie appears. And the genie says, I can grant you one wish as long as it is to do with the software project. And you say, okay, well, how about I can work on some cool new technologies? That would be nice. And the genie nods and goes away. And you think, was I just hallucinating then? And you get back to work. And then your boss comes in, and your boss says, build a mobile app? Really? A mobile app? What kind of mobile app do you want me to build? An iPhone app. Well, boss, I'd love to build you an iPhone app. Not that I've ever done that before, but it sounds fun. But you know, I can't do it using this massive old computer. I need you to buy me some new hardware. And the boss is not impressed, but he agrees and goes away. And a few weeks later, an exciting package arrives at your desk. Woohoo! You can now start developing some cool new mobile apps on your new hardware. So you get to work learning Xcode and Objective-C and all that stuff. And it's going well. And your boss comes back and asks for a demo. And you show him the work in progress. And what does he say? Social sharing? Ooh, well, that's going to make this really complicated. Because now, instead of just building an app, we need to also have some kind of back-end web service that can store the data. Oh, and that has all kinds of other requirements. So let's start to make a backlog of the work that will be needed. Firstly, you're going to have to build not only the app UI, but some kind of online backend with a database in it. And because you're a good developer, you know that it's also going to need some authentication there and some way of writing server-side logic because, you know, you need to protect users' data from each other. And your boss nods and says, yeah, get on it. And then the boss says, what? More Twitters and Facebooks? Oh, okay. Well, I suppose you mean that people should be able to log in with Twitter and Facebook accounts. That means you have to throw out the authentication system you were building and implement a new one with OAuth, which is a lot more complicated, and you've got to read a lot of documentation now. So this is becoming a big job. But you get to work. And then you show the boss the updated demo, and the boss nods and looks serious for a moment and says, oh, anyone got any ideas what the boss is actually asking for here? Use your software analyst skills. Push notifications, yes. The boss wants to be able to send push notifications to users. So you can add that to your backlog, and that means learning a new set of APIs. And because you need to send them at particular times of day, you'll need to have a system of running scheduled tasks that you've also got to implement. Okay, so you get back to work. And then what happens? The boss comes back, and you say, oh, I guess you've got some new requirement for me, have you, boss? And the boss says, huh? What do you mean? The app has not disappeared. The app is perfectly okay. And he says, oh, okay, boss. Well, the reason it's not on the Google Play Store is because you told me to build an iPhone app. And the boss does not believe your excuse and thinks you're just trying to, you know, trick him. And so he insists that you make it appear on the Google Play Store. So now you're going to have to build a multi-platform app. And this is getting really complicated now. But you get back to work. And then the next day, the boss comes back again. And you go, oh my goodness, what is going on now, boss? And the boss says, oh, right. This is getting very complicated. So how about instead of building a new native app for every platform, you implement a web-based version of the app as well, because then that can run on everything. And the boss says, OK, fine, and goes away. And then the boss introduces you to your new colleague. And you say, hello, new colleague, who are you? And he introduces himself, and he's kind of a big guy. You don't want to mess with him. And so, you make some friendly small talk like, what did you work on before? What's that thing on your head? Those kind of things. And then the guy explains his job. I'm the new tester, OK. So the new tester, who sadly has to use your old computer, gets to work on the app. And exactly 15 seconds later, he finds a bug. Because that's what testers do. So now you're going to have to implement some way of dealing with bug reports. You're going to need to be able to log errors and set up a diagnostic system. And this is getting super complicated, so much work. And you're thinking, well, if I've implemented all that stuff, surely there's nothing else I need to implement. But then there's a visitor. There's a knock on the door. Who's this? Anyone recognize this cheeky guy? Mr. Zuckerberg there from Facebook? What's he come here to say? Oh, right. Well, that's kind of good news, but it's also kind of bad news, because now we've got 500 million new users to deal with. So you're going to have to review your architecture and check that it really scales. So this is a terrifyingly difficult problem that you've got here. All that stuff you've got to implement, and you just wanted to build a mobile app. Wouldn't it be nice if instead of building all that stuff yourself, you could use a backend that already just existed, and you could just sign up to it? And that is obviously the promise of backend as a service, and that's what I'm going to be talking about today. So this talk is about Windows Azure Mobile Services, which is a backend as a service built into Windows Azure. And so it gives you a ready-made way of storing data in a SQL Azure database, of doing authentication against various providers like Facebook and Twitter and such like, writing custom logic in JavaScript that runs in a Node backend, sending push notifications to Apple, Microsoft, and Google mobile devices, running scheduled tasks at particular times of day, boring things like diagnostics logging, and, of course, being able to scale up to handle a lot of traffic. And as of today, we've got support for all the major client platforms. So that's Windows Store, iPhone, Android, iPad, of course, Windows Phone 7.5, Windows Phone 8, and HTML and JavaScript. So that's what I'm going to talk about today. But I'm going to talk about it in the context of building native apps specifically. So I'm going to build an iPhone app for you using Xcode and Objective-C. And I'm going to build a Java app using Eclipse and Java, even though it makes me feel really queasy and weird to do it. How many of you came to my talk yesterday, by the way? OK, good. Right, so maybe about a quarter of people there. So for those people, there's going to be some overlap with what you saw yesterday, because obviously there's a lot of central things that everyone else needs to see. But I'm not going to be using web technologies like I used yesterday. I'm going to just use exclusively native code. So let's have a go at building a couple of native mobile apps using Windows Azure Mobile Services as a backend. And I'm going to start by building a an Android application using Java. Because I'm going to be doing some iOS development, I need to do this on a Mac. So let's get started with creating a mobile service backend. Now, I'm in the Azure portal here. You can see that this is where I can set up websites, virtual machines, and other stuff. And I'm going to set up a mobile service backend. Now, I've already got some, as you can see, which is because I work on this project. But let's ignore those and create a new one. So let's create one called TechEd Native Apps, or something like that. It's just TechEd Native App. Okay. Now, it says I need to connect it to a database. I could create a new database, but I've already got one. So let's just put in the credentials for my existing database and let it connect to that. So that's now creating in the background there. That'll take a minute or something to complete. So while we wait, let me just show you a bit of the management interface. So on this first screen here, this is a kind of getting started guide, and we've got information about all the different platforms that we support. Nice little sort of tutorials for each of them. There's also a dashboard, so you can see in real time what your application is doing, how much traffic it's using, how much data and memory and things like that. You can also explore the data that you're storing in there and set up all kinds of other fun things that we'll get to later. But anyway, in the meantime, the app finished being created, so let's go into there and start actually doing something with it. So I want to start by building this Android application. So I'll go into the Android tab there, and you'll see we've got instructions for creating new apps or connecting existing ones. I want to create a new one. And the create new thing is a 3-step tutorial to build a to-do list application. Not because we think everybody needs to build to-do list applications, there are enough of them already, but just because it's a sort of common example that everyone can understand. And you can follow the same patterns in your own applications. So the first step is install the Android developer tools. Now, I've already done that. The second step is create a table to store the to-do items in. So I press the button and it's going to create this table for me. You can obviously create your own tables with different names if you want. And the third step, download your ready-made project. So I'm going to hit the download button there, and then that is now downloading in the background. So I'm going to open this project. I'll unzip it. It comes down as a zip file, and I'll extract that. And I'm just going to rename it to Android at the end there. So if I open this, you'll see loads of stuff related to Android development. How many of you have done Android development before? Ooh, that's more than I thought. That's like about 20%. All right, so let's have a go at actually running this now. So firstly, I need to open it in the IDE, which I'm going to use Eclipse for. There are other Android development environments available, but this is kind of the standard one. So when that pops up, I will go to import the project that I've just created. So import existing project into Workspace, and then choose the directory that I unzipped things into. So that's downloads, this folder here, and open that, and hit finish. And then that will import these files here. So I can now have a look and see all the files. I'll show you a bit of source code in a minute, but let's firstly run this project. So to run it, I've got an Android virtual machine right here. You can obviously use a real device if you want to, but this VM is quite convenient. And I want to run my code in that. So I'm going to click on this green play button here. And it says, OK, first you have to select what it is you want to run. So I'll do that and click Run again. How do you want to run this? Well, as an Android application, obviously, since that's what it is. And then the next thing is it has to detect the Android device that I want to run it on. So it's detected the device there, that's the virtual machine. And I'll say, use this device for all launchers, and go. So when that runs, then you can see the app has now appeared there. And as I said, it's a simple kind of to-do list application. So let's create a couple of entries. So let's have walk the cat, all in caps for some reason. Walk the cat R, why not? And add that one. And then let's also have feed the children, my second priority in the list there. OK, so I've got a couple of items there. And these items are not stored locally on the device. They are stored in Azure in the mobile service. Let's just prove that. I'll go to the Data tab and into that table, and you will see, when it loads the data, that those items that I've entered have shown up there. OK, so how does it work? Let's see a little bit of code. For those of you who are not familiar with Java, don't worry. I'm not going to show you too much. There will be a bit of Java in this talk. So you can see the APIs work like this. Firstly, there's an object of type mobile service client, and that gets created when the application first starts up. So it creates an instance of mobile service client and points it to the URL of this app. And then that thing is able to get references to tables inside the app. So this gets a reference to the to-do item table. And then later on, it's possible to use that table to run things like update operations, also insert operations, and queries. So this does a where query, where complete equals false, and then when it gets the results, it displays them in the UI. But we won't worry how that works, because that's just Android stuff. But you can see the APIs are quite straightforward there. Right, now let's do the same for iOS as well, because I'm going to kind of develop the Android and iOS versions of this app in parallel. So I'm going to go to the iOS tab here and follow the same steps as before. Now I've already installed Xcode, I've already created the table, remember, so I'll just download the ready-made project there. So that's now downloading, and I'm going to unzip that when it finishes downloading. Which will take another few seconds. And then I will open it in Xcode, which is Apple's IDE for these kind of things. So let's unzip that, and then I'll rename that to iOS in the file name. And if we look in there, you'll see there's an Xcode project. So I will open, all going crazy, open with Xcode. Okay, and that pops up there. How many of you done iOS development? Ooh, maybe slightly more, maybe 25%. Okay, right then. So let me show you how this works. And in fact, let me just show you it running first. Let's run it in the iPhone simulator. I'll click Run. And you'll see it's very much the same thing as before. So same data, because it's connecting to the same mobile service, and I can enter some more text here. So if I had an iPhone, what would I want to do? I would probably want to remember to buy a Windows Phone. Okay, add that to my list of tasks there. Okay, so and let's just check that that actually shows up in Android as well. If I hit refresh, you'll see it does, because of course it's the same backend. So how does it work? Well, again, I'm not going to focus too much on the details of Objective-C, but just to give you a vague idea, here's the view controller that's running there. You'll see it, wrong thing I want to show you is the service. Now, the service is kind of a data access class. So this encapsulates all logic that talks to the back end. And inside there, you'll see it creates an instance of mobile service client. That's not Microsoft client, it's mobile service client. And it points it to the same URL as before. And then it's able to get a reference to a table inside there, just like in Java. And then it's able to do things like a query. So this does a read with predicate. And the predicate is the query, where everything complete equals no. And then also it can do things like an insert, fairly straightforward, and things like an update, pretty straightforward as well. So if you know Objective-C, you will hopefully not be scared by this code too much. If you don't know it, I appreciate it looks very alien, but don't worry. Hopefully you can still follow this talk even without that. Just accept that it's reasonably straightforward to do that. Okay, so that's all very nice. It's been possible to, in a few minutes, get a starter project that runs on both iOS and Android, and we've also got the same starter project for Windows Store, Windows Phone, and web applications as well. Now, the way it works so far, the client devices are able to access any bit of data they want on the server. So they can insert anything, update, delete anything at all with no controls whatsoever. You don't have to log in. You don't have to satisfy any validation rules or anything. How could that possibly go wrong? Well, I think pretty much everyone in the room would be able to guess that it's not a great situation to leave your database completely open to all client applications, because people might send you unexpected data, access other people's data, delete stuff or whatever, just by making HTTP requests to your back-end service there. So you need a way of writing server logic to control what people can and can't do. And not all back-end as a service products really have a good way of doing this, but mobile service is extremely strong in this regard. Let me show you how it works. Let's come up with a little business problem that we want to solve. So the problem I want to solve is, how do I get that button to vanish from my screen? This one here. Okay, that's good. The problem I want to solve is, let's say that we want to keep track of when items were marked as completed, because maybe when something gets completed determines when somebody gets paid or something important like that. So we want to have a complete date column in this table, and we need it to be accurate. And we can't trust the clients to send us accurate timestamps, because for one thing, the clock might be wrong on the device, and for another, they might be deliberately crafting incorrect timestamps. So is the mic still working? Can you hear me? Yeah? Sounds quiet. Okay, so we want to capture a timestamp on the server, not on the client. Now I'm going to go into this script tab here, and you can see that we allow you to write custom scripts that run on update, insert, delete, or read. And you can write custom scripts at other times as well. I want to write one that runs when someone updates a record. And the logic I want to write is, if you've marked something as completed, then we'll get a timestamp. So if item.complete, I'll set a new property on this object, complete date equals new date. Okay, and I'll save that. Right, so this is JavaScript, as you can see, and at runtime, your application is actually a Node.js application. So you can write any code that would work inside Node.js, and it will run on the server inside mobile services. And this is really powerful, and I'm going to show you some great applications of that later. But this is just to get us started. So let's try this out. Now, firstly, notice that there is no column here called complete date. So you might think, how can I insert a value into it then? Is that going to be an error? Well, let's see what happens. I'm going to mark this item, feed the children, as complete, okay? And we'll see, does it give me an error? Well, we don't know. Nope, it doesn't give an error, okay? And I'll hit refresh. What happens is it's automatically created this new column for me. And this is a feature called dynamic schema. The idea with that is you can accelerate your development process by not having to define all of the schema up front. We will automatically update the schema to match whatever type of data you want to store. It just is convenient for you. You can still manage the schema manually if you want to, because it's a real SQL Server database behind there. And you can connect Management Studio to it and add your own columns and all that stuff if you want to, but you just don't have to. Now, when you go to production, you should turn that feature off, because if you don't, people might send you unexpected data and you would just start storing it. So there's this big, fat blue button here on the Configure tab, and you should turn that off when you go to production. But in development, it's really nice to leave that on. Right. So it did work. Look, we have in fact got a timestamp on the server. The client didn't have to send one, and even if it did, we would have ignored it and replaced it with a server timestamp. And it works on both devices. So if I mark walk the cat as complete as well, then if I go back and hit refresh here, then of course, because that logic runs on the server, it's shared across all devices. And that's marvelous. So we're doing pretty well, I think, with that. Now let's add just another item. Let's just have something else and add that. And then finally, I'm going to refresh. And so those are my two remaining tasks. Now, I've got a bit of a problem here as somebody who uses this app. And that is, you know, at the end of the day, when I've been really productive and I've got all of my work done, it's really boring to have to go down the list and click the button on every single thing saying, mark that one as done, and that one, and that one. I was so productive today. Wouldn't it be nice if there was a button that just marked everything as done all at once? You could shave maybe 3 seconds off your workday by pressing that button. So I think that would be well worth implementing. But there's a little bit of a problem with implementing that. Where is the logic for that going to go? It can't really go on any of these operations, insert, update, delete, or read, because it's not an operation relating to a single record. It's an operation relating to multiple records. So where would we put the logic for that? And that opens up this question. REST versus remote procedure calls. Now, REST is one architectural style for working with a backend, and that is the table operations. Your inserts, updates, deletes, and reads, or in HTTP terms, get, post, patch, and delete. And that's great. It's really valuable to have that, and you've just seen it. But there's another type of operation as well, remote procedure calls, and those are not related to any particular single entity on a record. So for those, you might want to do things like moving data between tables, or running an operation on multiple records, or aggregating over multiple records, or anything else. And mobile services supports that style of programming as well. So let's have a go at implementing an endpoint call for the remote procedure call style. And remember, what we want to do is a mark all as completed. Now, I'm going to do this in the iOS application, and there are a few steps that we need to go through. So here's a little bit of tutorial about doing iOS development. To wire up a custom operation for iOS, we're going to need a few things. Firstly, we'll need a visible button that the user can actually click. And for iOS, you will typically do that using something like the storyboard, which is a visual design tool. Some experienced iOS developers prefer other ways of adding buttons to screens. That's fine, but we'll just use the basic visual designer for this demo. The next thing is that visible button will have to do something when it's clicked. And in iOS, there's a concept called view controllers. And you can think of that as being kind of a code behind file for the visual designer. So we'll need to add some logic onto that. And now that thing needs to do something. What's it going to do? Well, we don't want to call the mobile service directly from there. It's good practice to kind of encapsulate your data access into a separate service class. Most iOS developers will do that. So we'll follow that pattern and create a service operation that encapsulates this. So this is all iOS stuff so far, no mobile services. But finally, your service operation can actually make an HTTP request to the custom API on the server, which will actually do the thing finally. So let's do this. And let's do it in reverse order. So I'll start by implementing the custom API, and then we'll go through all of the other stuff. So let's implement a custom API. I'm going to go to the API tab here, and you'll see I've got no custom APIs yet. Let's create one. And we want to create one called mark all done. That'll do. And you can see you can set up permissions for who can invoke that. Let's not worry about permissions yet. We'll get on to authentication later. So that's created. I'll go in there, and you'll see you can write some arbitrary script that runs there. And what we want to do is write a little query that updates the status of all items to completed if they're not already completed. Now, mobile services supports two querying syntaxes. We have a JavaScript-based query syntax and just plain old traditional SQL. And for the sake of familiarity, I'm going to do this one in plain old traditional SQL. So let me drop in a bit of code that I've already got. And you can see it's going to update all the to-do item records where they're not completed yet to set them to be completed and stamp the current date on them. Okay, so I'm going to hit save on that. And hopefully now, oh, actually, I called it complete date, not completed. Okay, so hopefully that operation is ready to go. Anyone who hits that with an HTTP request will effectively mark all items as complete. So that's a good start. We've done our custom API. Next step, let's implement the actual service operation for the iOS app. So I will go to Xcode. I'm going to go into my service class. Now this is a header file, and this defines all of the operations on this service, and it's Objective-C. Don't worry if you're not familiar with that. So, wrong thing. There we go. So I've just added this little code snippet there, and that declares that there's going to be an operation here called mark all done, and it doesn't take any parameters, and it doesn't return anything either. It just does what it says it's going to do. Now that's just a header file. You need to provide an actual implementation. So I'll go over to the implementation file, and somewhere near the bottom, I'm going to drop in an implementation. So here's my ready-made implementation. And what it's going to do is it's going to get the client instance and invoke the API on it, the mark all done API. It doesn't have to send any parameters or body there or any headers. It's just going to send a post request to mark all as done. And when it's completed, it doesn't have to do anything. So it's just an empty block that runs after it's finished. Okay, good. All right, so that wasn't too bad. We've got a service operation now that knows how to invoke that API. Next step in the chaining up process, implementing the operation on the view controller that can call that service method. So let's go into the view controller here. And again, I need to declare something in the header file. So far, there's just one action called onAdd. Let's create a new action as well. So let's create an interface builder action called onMarkAllDone. Okay. Now, this IB action thing means that it can be connected to something in the visible user interface. And you see that little circle next to it? The fact that it hasn't got a dot in it means I haven't connected it up yet. So I'll connect it up in a minute. But now you have to provide an implementation for onMarkAllDone. So let's go into the implementation file and put an implementation in. So onMarkAllDone, the implementation is going to do what? It's going to do self.to-do service mark all done. Okay, that's all it does. It grabs the to-do service and calls mark all done on it. Okay, pretty trivial there. So wrong thing. Right thing. So you can see we've now got an operation on the view controller. It's kind of boring, but you can see it's all fitting together. Finally, the interesting bit at last, let's connect it to a visible button in the user interface. So I'm going to go to the storyboard now, and for the iPhone application here, and I want to add a button onto there. So let's get the object library down here, and I can find a button on the object library. Let's get a round rectangular button, and I'll drop that in here. Okay, put some text on it. Let's have mark, let's just call it I'm done. Okay, and now I need to link that up with the operation on the view controller. So I have to perform a really weird gesture at this point where I hold down the control key and drag the button onto the thing that it's on. Very strange, but that's a way of linking it to an operation on that view controller. And when I release the mouse, you'll see I can connect it to either on add or on mark all done. So I'll connect it to on mark all done. All right. So hopefully now I've wired up everything together. Let's see if it actually works, shall we? I'll bring up the application, and you'll see there are 2 items there, and I'm going to click I'm done, and there's no errors, that's good. So when I next refresh, we should see there's nothing left in the list. Everything's gone away. And in fact, if you go and have a look in the actual data browser, we should see that all of those items have been marked as complete. So it worked, and that's really nice. Now, let's see where else we can take this. So let me just add a couple more items because we're going to need some more things. Let's put alpha and beta in there. Right then. So what's next? We've been able to create a mobile service that runs on and that connects to native apps on multiple devices. We've been able to write some custom logic that runs when you do inserts and updates and stuff. And we've been able to write some custom logic that runs at arbitrary times, like when the user clicks a button. And that's great. But what if you want to run some custom logic at a different time, maybe when no one's even using the application at all? Like, what if you need to run some logic at, say, 6:30 a.m. every day? Maybe you need to back up some data. Maybe you need to run some kind of cleanup task. Maybe you want to send people some emails. But you don't want it to be just in response to a user action. You want it to be scheduled to run at a certain time of day. Well, you'll be pleased to know that mobile services supports that very well. So let's have a go at implementing a scheduled job. And the idea here is I want to solve a real problem that we've all got. And that problem is how to get a promotion. Now, I don't know about you, but in my company, the best way to get a promotion is to make sure that your boss knows about all the amazing stuff that you do every day, and also his boss and her boss and everyone up the chain. Make sure everybody knows that you're amazing. How are they going to know that you're amazing? Well, they need to know what you've been doing. And that's great because you've already got a to-do list application, so you know what you've been doing. You can use that information maybe to send a daily message with a list of your accomplishments to your boss. Wouldn't that be great? But your boss is a busy person. He doesn't like to read long emails. So how about sending a daily tweet of your accomplishments to the boss? That would be really nice. Let's have a go at implementing that, a daily tweet. Well then, let's start by defining a scheduled job. So I'll go to the Scheduler tab. There are no jobs scheduled. Let's create one. And I'll call it Tweet Boss. Now, how often should we run this? I suggest not running it every 15 minutes. That probably would annoy your boss quite a lot and maybe doesn't result in getting a promotion. So we'll run it on demand and we'll set up a schedule later. Okay, go. Right, so that's creating a scheduled job for you now. And you can write some custom logic that runs in that. So let's go in and have a look at it. And you can see you can configure it to run whenever you want, and you can write your custom JavaScript that runs in there. So what do we want to do? Well, we want to send a daily list of accomplishments. So first, we need to get the list of accomplishments. So we want to run a query against the database to see what you've done in the last 24 hours. Now, again, you can use either JavaScript or SQL query syntaxes for that. And I am going to use just some straightforward SQL here. I'll use the other query syntax later. So here's my query. I'm going to select all the to-do items which have been completed in the last day. And then when we've got all of those items, we want to get the text from them. So we'll iterate through all of those items and get the text from each item. And then we'll have an array of all the text values. And we can join them all up into a single string with commas in between them so that there's one message saying what stuff you did in the last day. And then finally, just to check it works, we can log it to the console. And you may think, what console are you talking about? I will show you. So firstly, I'll save that. And then when that has saved, I'll hit run once on that. Run once is just to sort of test this now button. So I'm testing that by running it. And I'll go and find where the console log messages appear. They appear on this log tabs here. So if I go in there, we'll see, oh, look at that, I've got an error. So the console log is a really good way of finding out when you've done something wrong. Really helpful when you're in the middle of a presentation. So let's see if it gives me a good error message. It says, invalid column name, completed date. Okay, that's great. I know exactly what I've done wrong. So I can go and have a look at that script again. And remember that I didn't call it completed date, I call it complete date. So let's fix the script there, save that, and run that again. So there we go, an extra free demo for you there, unexpectedly. And I'll go and look in the logs tab again now. And you'll see this time there's no error, there's just an informational message. And it's logged, Steve did walk the, whatever that thing is, feed the children, and so on. So there we go, a very productive day that I think my boss will be impressed with. Okay, but remember, I don't want to just log stuff to the console. I want to send a real tweet to my boss. So here's my Twitter account, my fake one, and you can see that I've been busy writing lots of witty tweets that everybody is excited by and wants to follow. And I want to send a message from this account. Now, mobile services does not have any Twitter, well, it doesn't have send tweets feature built into it. But because it has custom scripts, you can integrate with all kinds of third-party APIs, such as Twitter's API. Now, Twitter has an OAuth-based API, and it's very straightforward to use that from a mobile service script. So let me implement this. I'm going to add a little utility function called tweet, which sends a tweet from my user account. So let's drop this in. Okay, so here's the implementation. Firstly, limit the message to 140 characters, because that's what Twitter requires. And then I want to send an HTTP request to Twitter. Now, because this is Node.js behind the scenes, the way Node does importing libraries is this require statement. How many of you have used Node? Whoa, maybe 10%. Okay. So for everyone else, the require statement is like an import statement, kind of, except it's at runtime. So I'm getting the ability to send HTTP requests. Then I'm setting up a URL, and this is Twitter's API URL. I'm setting up what message we want to send, and I'm setting up some OAuth parameters. Now, all of these keys I got from Twitter when I registered my app with them, and I'll show you that in a minute. But then I can send the HTTP post with this URL, those contents, and all signed with these OAuth parameters. So it's not too difficult. Okay. Now, I want to use that. So instead of just logging this message, let's actually invoke the tweet function here. So I am going to tweet this message, and if there's an error that comes back, we'll log it to the console. Right, let's see if it works, shall we? I'll save that, and then I'm going to hit run once, and hopefully it will have now sent a real tweet. So let's go back to twitter.com and refresh, and you can see, there we go, it did send an actual tweet. So I can very easily now just put @myboss, and then the message will really go to him. And I can do that every 15 minutes and get a promotion, I'm sure. Now, we don't just want to run this by clicking this button manually. We want to make it run automatically every single day. And that's very easy because it's a scheduled task. So I'll say every one day starting at, let's say, 8 a.m. So my boss gets a message with his breakfast every day, and he'll be constantly reminded how great I am. So I'll save that. And then finally, the last step is to actually enable this job. So you can enable and disable things without having to change the configuration. And once something has been enabled, you'll see that you can see when it last run. It's never run on a schedule, but it is scheduled to next run tomorrow at 8 in the morning. So we know that's going to work. So that's great. I think it's very likely that we'll get a promotion now, and we can feel good about that. Okay. Now, next thing. I'm going to show you another really exciting feature in mobile services. And this is going to solve another problem that you will have in your development process. Now, let's say you're using this to-do application to track all the tasks that your team's got. For example, all the bugs that need to be fixed and all of the deployments that need to be done, that kind of thing. Now, today, one of your employees is working from home. And the employee who's working from home has accidentally forgotten to run the app that tells him what tasks he has to run today. So there's no way of contacting this employee and telling him that he needs to fix some important bug. But wouldn't it be nice if there was a way of getting a message? If you could somehow make your app send a message that just appears on his phone, and there's no way he can avoid knowing that there's some important work to be done. It might freak him out a little bit, but let's have a go at doing this. So I'm sure you can guess the way this is going to work is by sending a push notification. Now, push notifications are built into all the major platforms, Windows Phone, iOS and Android, and Windows Store applications as well. And mobile services supports sending push notifications to all of them. And they can be sent and received even when the user is not running your app. Now, this is a technically intricate thing to implement. I'm going to show you how to do it for Android, and I'm warning you now, this is not easy. There are quite a lot of steps involved in doing this, some of which are not obvious. And the reason I'm going to go through it step by step is because when you want to do this yourself, for real, I don't want you to freak out and think, surely it can't be this hard. You'll remember back and you'll think about this session and you'll think, oh yeah, it is that hard, unfortunately. But hoping that you will follow along as I go through and do this. So there are a few steps. Firstly, you need to ask for permission to send notifications to this user. So you need to get what's called a token, and the token kind of identifies the device and lets you send messages to it. And then you need to be able to send messages to it. Now, there's a few steps in getting a token. First, you go and register yourself with whoever, like Microsoft, Google, or Apple, it is that you want to send messages to those kind of devices. Then you need to write some code on the device that gets one of these tokens. Then you want to send that token up to your mobile service so that it's stored and is ready for you to use. And once you've got that token up there, you can send messages to the person who generated that token. And finally, depending on what device it is, you may need to write a bit more code to receive the message and make it get displayed on the screen. Okay, so are you ready? We're going to do this. It's quite difficult, hoping you can follow it, but if you can't, don't worry. You can refer to the session video later, or you can look at the documentation where we've spelled out all of the steps. So, first step, register the app. And I'm going to do this for Android, so I need to register with Google. Now, I've actually already registered with Google, so when I did that, they gave me a Google Cloud Messaging key, and I can drop that into the portal here. So let's drop it in my GCM key. You can see it's this big long string, and so I will save that. So now my mobile service knows how to send messages to Google. All right, so it seems all right. Maybe this is not going to be too bad. We've got the first thing done already. But now comes the difficult bit, getting the token from the device. So let's write a bit of Android code to try and get a token. I'm going to go into Eclipse here. And the first step is to do a bit of configuration. So before you can request a token, you have to add a permission to your application. This is a bit like a web config file or app.config, and you say what permissions your app needs. So I need the permission to get push notification tokens. So I'm going to add all of these permission things. Now, this is all described in the documentation, so don't worry if you can't remember it. I do have to copy and paste the package name in a few places. So I'm going to paste that here and here. The package name is just sort of the name of the application. Okay? So now I've got permission to work with Google Cloud Messaging. The next thing is I have to register the fact that my code can receive messages. And that's a little bit more configuration. And again, this is all in the documentation. So let's insert a little bit more configuration in here. And here's the next block. Here we go. So what have I just added? I've added this receiver. The receiver is some code that can receive messages. And again, I need to fill in the package name and other stuff that's not interesting to talk about. All right, so that's all of the boring configuration out of the way. The next thing is to start working with some code. Now, when I've got the token, the push notification token back from the server, I need a place to store it on the device temporarily. So I'm going to add a couple of static fields into my code here. So I'm going to add this field here. This is a static field called channel for user, and that is going to store the token for this particular user when we've got it so that we know who to send the messages to. I also need to know what my app ID is because Google needs to know that in order to issue these tokens. All right. Now, next thing, write a bit of code that actually asks the device for a token, or at least sees whether or not we've already got one. So I'm going to drop that in here. This is on the application create. We're going to write some code to ask for the token. And here is the code for that. A little block of code here. Now, before I can use this, I need to import some namespaces. Now, I can't import the namespaces yet because I haven't referenced the correct library. So in .NET world, this would be like trying to use a class library that's in an assembly that you haven't even referenced yet. So how would you reference the assembly? Well, in Eclipse, the way you reference things is that you drag them into your lib folder. So when you install the Android SDKs, you get lots of jar files that are different SDKs. And I've got Google Cloud Messaging.jar, and I'm going to copy that and drop it into my libs folder here. And so I'll say, OK, copy that in. And now I've got that thing there, I can hopefully import the namespace for these Google Cloud Messaging APIs. So I've done that now. Right, so what does the code do? It checks whether or not this device has already got a push token. It tries to get any token that we've already got. And, ooh, what did I just do? I don't know what I just did there. Let's try and undo whatever I just did. I don't know what I just did. Maybe I just unimported the namespace. Let's try that. And hit save. OK, hopefully I haven't broke anything. So it checks whether or not we've already got a token. If we haven't already got a token, then it tries to register for one. Now, that's an asynchronous process, so the result will be received later, and you need to write some more code to receive that result and store it. So to receive that result, you have to add a new class. So let's add a new class here, and I'm going to call it GCM Intent Service. Google Cloud Messaging Intent is some code that can run at an arbitrary time, and it's the service to receive that. And I need to inherit from this GCM base intent service here. So here's my new class that inherits from this standard base class. And you can see it's got all of these callbacks. There's a callback when you receive a message, a callback when you successfully register and get the token. So rather than filling that all out step by step, I'm just going to drop in a complete implementation there. Because it's kind of boring. And you can see that when the user has registered and they've got the token back, we'll store it in that static field. And I've also added a bit of code that says when we get a message, we'll display stuff on the screen. And I'm going to change the title a little bit. So I'm going to display the title, job was completed, because I'm going to send messages each time a task gets completed. Now, the last thing is I've got an error, which I'm referencing the wrong package name, so let's reference the correct package name, which is TechEd Native App. Okay, so we're very nearly done with making this work now. We've successfully, hopefully, requested a token from Google, and we've now got that token on the device. But it's not good enough just to have it on the device. You need to pass it up to your mobile service in the cloud. So how can you do that? Well, the way I'm going to do it is I'm just going to include the token information with each to-do item that gets inserted. So let's go to the to-do item class here, and I'll add an extra field to it, which is the token that can get sent up to the server. So this is these sort of 10 lines of code here. That is equivalent in C# to writing public public string channel get set. Okay, so all of this nasty Java code is equivalent to this one line in C#, so you know what that does now. Okay, and I need to populate that with the actual channel information that we've got. So what I'll do is I'll go back into the main part of the application, and when we're actually adding an item here, I'm going to set the channel value on it. So I'll set channel to channel for user. Okay. Right, so tons of stuff that I've just implemented there, and I'm sure most of you have lost me somewhere along the way, but don't worry, it's all about to get a little bit simpler now, assuming that this code actually runs and works. Let's see if it works, shall we? So if it works, then when I insert a new item from Android, the dynamic schema feature should create a new column on here called channel, and it will store the push channel for this particular user, so we can use it later. Now let's see if it does work, shall we? I'm really hoping it does. So I'm going to run the code again, and when that pops up in the device, I'm going to insert some new item. So let's have fix the bugs, okay? And we'll hit add on that, and hopefully it will have actually worked. Let's see. I'll hit refresh, and you'll see we've got the channel column there, and I'm very relieved to see it has in fact got an actual channel token from Google that's been stored there. Fantastic. So we're doing really well. We've saved the token. And remember, I also implemented a little bit of logic to display messages when they get received. So finally, all we have to do now is actually send the notification. And that is something that you would do from the server. And the APIs, because we invented them, are really simple and fun to use, unlike all of the Java ones. So we'll go into the script tab here, and I'll add a bit of script that runs when an item is updated. And I'll say, if the item has been completed, then I want to send a push notification. So the code for sending the push notification will look like the following. Okay. So hopefully you'll agree it's not too bad. We're saying if we've got a channel token for this item, then we'll push, using Google Cloud Messaging, through the channel on this item, some text that's been entered. And if it succeeds, we'll log that information. And if there's an error, we'll also log that information. Okay, so not bad. I'll hit save on that. Now then, moment of truth. Let's see if this thing actually works. So I am going to mark an item as completed, and hopefully we'll get a notification, even though the Android user is not currently running the app. Now, look closely at the top left-hand corner of the screen. You'll see there's no icon there, it's just black. That's where the icon will appear, for those of you who don't use Android. So on the iPhone application now, let's refresh, and I'm going to mark this item, fix all the bugs, as complete. And when I do that, you'll see in Android, would you believe it, a little icon has appeared. So we've sent a push notification and it's been received. And if I expand that, you'll see, ooh, come back, job was completed, fix all the bugs. Hooray, so our user knows it was done. And you can click on that and it will go into the app and you can see that fix all the bugs is not there anymore. So it worked first time, I'm quite pleased to see. So it's possible to send push notifications. And it's a real mess trying to set up all of the configuration and stuff, but that's just to do with what that device requires. It's, I don't want to sound too much of a Microsoft fanboy, but it's literally a one-liner in Windows Store to request a push channel. You don't even have to register with Microsoft in advance. So you'll have a relatively easy time there. With iOS, it's probably slightly easier than with Google as well. The complication with iOS is that you need to have a special certificate from Apple. And although that's fine when you've got one, I didn't really want to use it during the demo because if that went wrong, there would be no way for me to fix that demo. So it's not so bad in iOS. It's great in Windows Store, a bit difficult in Android. But hey, once you've implemented it, you're OK. Right then, let's move on to something different. Here's your boss, and your boss has got a bit of a concern. Your boss's nephew, who's 15, is a bit of an aspiring hacker. And she likes to look at all the work that her uncle's company does and try and find exploits and break them. And your boss is slightly nervous about this, and he's hoping that this app is secure. So he's giving you a little bit of an ultimatum here. You need to build a secure app, otherwise you're going to be out of work. And right now, this app is not secure at all because there's no restrictions on who can access it right now. Anybody who knows the URL can start making requests to it and get information about all of the jobs, the tasks that are being completed, and even mark stuff as completed. So what you would want is a way of forcing people to log in. So how about we force people to log in? You can do that with custom script, or the even easier way is you can go to this permissions tab. And for each of the operations here, I'm going to say you can only do the operation if you are authenticated. Okay, that means logged in. So I'll save that now. And let's see what effect that has on the application. I'm going to go back to Android, and I'm going to try to refresh the data. And this time, instead of working, it's going to give me an error. And that's because the server will not return data anymore. It's now returning 401 unauthorized. So how are you going to make your application work again? Well, you're going to need to have a way of making people log in. And what kind of login system are you going to use? Well, Mobile Services has got a range of different login providers built into it. We support Microsoft accounts, Google, Facebook, and Twitter. And if you like, you can even roll your own authentication service, because we've got some APIs that allow you to provide your own authentication tokens. We've got a couple of other authentication providers in the works. I just got an email about that this morning, but I don't know how soon they're going to be released. So these are the 4 that you've got right now, and you can roll your own if you like. Now, let's say that you want to log in with Twitter, because you've already seen that it was possible to use the Twitter APIs. So let's see how to use them for logging in. Now, I'm going to go over onto this Identity tab, and you can see that we let you set up authentication through Microsoft, Facebook, Twitter, or Google. And for each one that you want to use, you've got to provide some information that provider needs. So in the case of Twitter, we need a consumer key and a consumer secret. But what on earth is that? Well, the way to get your keys is go to this website, dev.twitter.com, and sign yourself up as a developer with Twitter, which is free. And when you've done that, you can register your apps with them. And when you've registered your app, they will give you all of these keys and URLs and things like that. So all you have to do is copy and paste these values. So I'm going to copy my consumer key, and I'm going to paste that in here. And I'll copy my consumer secret, and I'll paste that in here as well. And I'll hit save. OK, so now the back end is able to authenticate itself with Twitter and thereby work with Twitter's login API. So that's good. But the app still doesn't have any login user interface. So how can we add a login screen onto this? Well, one way to do it would be to crack open Storyboard and start adding login buttons and text boxes and things like that. And that would be kind of boring, but you could do it. Another way that you can do it is that you can use the login user interface that's built in to the mobile services SDK that we provide. So you can do it in relatively few lines of code. So let's have a go at doing that. And I'll do this with iOS. So how can we add a login screen? Well, I'm going to go to my view controller, because that's where all of the logic relating to actually the user interface is. And you can see that there's various bits of code that run at different times. There's some code that runs when the application loads, and so on at other times. I want to write some code that runs after the screen appears to the user. So I'm going to add some extra stuff, if I can find it. Here. Right, so I'm going to say, after the view has appeared, I'm going to check whether the user is already logged in. So we'll ask the mobile service client, has the user logged in? And if they haven't, then we want to perform a login operation. Now, that's what this perform selector means. So you need to provide an actual implementation for login, and I will drop one in right here. So here's an implementation of login. It's a bit of a chunk of code, but it's not too bad. So let's see what it actually does. It's going to get a reference to the mobile service client, and it's going to create a login user interface, which is configured to work using Twitter. And you could put Facebook or Google or whatever in there. And when the login has completed, it'll check for errors. And if there has been no errors, then it will try to refresh the data for this user and make the login screen go away. And then finally, it displays that login screen with an animation. So hopefully that's all that's necessary. And all of this code is in the documentation for mobile services. So hopefully you don't have to just remember what I've seen, what I've presented. OK, let's run this. So when this pops open, now a login screen appears, and it should be, if Twitter is not down today, a Twitter login screen, and here it is. So I will sign in with my account. OK, and just so you can't see my password, I'll move that down here, because that's the nice thing about demoing on iOS, is that you can see the typing. And then I will authorize that. So now it goes back, and this time there's no error. It is able to actually get the data. OK, that's good. So now we know who the user is. But we don't just want to know who the user is. Let's do a little bit more with it than that. Let's say we want to have a separate to-do list for every person who logs in and restrict people so they can only see their own data. Now, that's very easy to implement with a bit of custom script. So I'll go into the script editor, and I'm going to say we'll have a bit of extra logic that runs on insert. And when the item gets inserted, we're going to track which user owns it. So I'm going to create a new property on there called owner ID. And that's just an arbitrary string. I could call it anything I want. And I'm going to initialize that to be the user ID that the person is logged in as. And this value here, that's all verified on the server. So you know that really is who the person logged in as. OK. So if that works, we should be able to see the Twitter login user. Let's create something new called I am authenticated. Okay, let's add that. And if it works, then when I refresh, we should get the owner ID column appearing there. And if you look, we've got the Twitter user's name. So we know which user owns each record now. Now, how about we restrict people to see only their own data? That's very easy to achieve as well. I can go into the read script here, and I'll say, when you try to perform a query on the server, I'm going to add an extra where clause to it. Now, this is the JavaScript querying syntax that I've mentioned a few times. And I'm going to say we're only going to return records where the owner ID is the person who's currently logged in. So you can't see anyone else's data anymore. Let's see if it works, shall we? If I refresh this data, then hopefully I can still see I am authenticated, but I won't be able to see alpha and beta anymore because they're not associated with my user account. So I refresh, and you see I can only see my own data now. So that's great. Not only can we log in with third-party providers or custom providers, it's possible with just a couple of lines of server-side script to implement whatever authentication logic is required to restrict data to the right users in your application. And that's great. We're doing really well. Now, how about we make this a little bit more advanced and interesting still? So before I introduce this next topic, I'm just going to press a button, because it takes a few minutes to run. I'm going to press Set up Source Control here. Do I really want to do that? Yes, I do. Now, why would I want to set up source control? Well, the reason I want to set up source control is because, obviously, all professional developers use source control. So far, I've been doing all of the work in the web browser. I've been entering all my scripts there, and I've been making all my changes like that. And that's fine, but it's not a particularly great editor, and I don't have any version history there, and it's hard to collaborate across multiple developers. So, of course, it's much better if you can store all of your scripts in source control and all of your table definitions and that kind of thing. And that's what this feature allows you to do. Now, this is a preview feature that we're only just bringing out right now. So there's potentially a bug in here I'm wondering if we're going to hit. And it also takes a little while to run, which is why I started it before I started talking. And yes, you can see we've got the little bug where it claims that it failed with an error, but in reality it didn't fail. It will have actually succeeded. And we're going to fix that. I think the fix is going out today. But anyway, if I come over here onto the Configure tab, and I refresh that a couple of times, multiple times, in fact, until it's eventually succeeded. It's going to succeed eventually, honestly, because otherwise it kind of spoils my demo. Come on, give me the source control. If this doesn't work, I'm going to switch over to a different app that I've already prepared that does have source control enabled. Come on. All right, last time I'm going to try it, and if it doesn't work, I'm going to switch to a different app. It did. Hey, there we go. So that's the workaround for the bug that we've got in production today. The fix, I understand, is going out today, or maybe tomorrow. I don't know. So hopefully you won't hit that issue. But anyway, you can see it's using Git. So it's given me a Git URL. How many of you use Git? Good. I am relieved to see there's a good number, maybe nearly a half. Now, Git works with TFS as well, so those of you TFS people are not being left out. Git is a really nice system, and I'm going to check out my repository here. So I'm going to copy that URL, and because it's a Git repo, I can use any Git client I like. Now, just for the sake of simplicity, I'm going to use the Git command line tools, but you can use other graphical tools if you want to. So I'm going to do git clone and that URL. Here we go. So that's going to ask me for my password, and I will enter that. Notice that I can't speak at the same time as typing my password. And apparently I can't even type my password even while I am speaking. Come on. Authentication successful. Come on. Yes, okay, good. Right, I typed it correctly that time. So now we've got a local copy of all the scripts that we've been using. Let me show you. I'm going to pop it open in one of my favorite text editors, Sublime Text, but you can use any one that you like. And I will show you that stuff that I've just checked out. So it's on my desktop, TechEd native app, and I'll open that. And I will zoom in once I've expanded all this stuff. So you can see all of the scripts that we've built so far are here in this repo. So there's mark all done. You can see that one. There's the tweet boss script. And there's the, all of the table scripts that were implemented. So you can now work with those offline. And that's great. But what would be really interesting now that you've got the source control code locally? What if you could do a bit of local development, not using the cloud? And what if you could even pull in third-party scripts? Because if you're going to build a large, serious application, then you probably don't want to write all the code yourself. You want to be able to reuse third-party scripts. Now, maybe you're used to using NuGet in .NET. Well, as I've mentioned, the runtime here is Node.js. And Node.js has an excellent package management system called NPM. And it's a very vibrant ecosystem. 33,000 packages on there, more than 1 million downloads per day. This is a serious ecosystem. So any kind of package you want, there are 5 of them on there. And you just have to find the one of them that works, and then you're going to be able to write a great application. So let's have a go at actually bringing an NPM package written by some third party into the application and doing something interesting. And what I want to do is implement our own special version of autocorrect. Because there's a little problem right now, which is that people keep typing things in with typos. Let's enter something with typos in it. So let's have, please correct all spelling, okay? And so there's all kinds of typos in that text there. And when I enter it, you'll see that all these typos ended up in the database. And I don't want typos in the database. I want them to be automatically fixed. Now, believe it or not, there's no spell checker feature built into Azure Mobile Services, but it's possible to get one from NPM. So let's do a little web search. Let's do NPM spell checker. And if I run that, you'll see that there are several spell check modules available. And I'm going to use this one called Speller. So if I go in there, you'll see it tells me the way to install it is npm install speller. So I'll copy that, and I'm going to install that package. I'll go into my service folder, what's it called? TechEd native app service code. So that's where I've got all those scripts already. And I'm going to do npm install speller. So that's going to download the speller package from the web now and install it into my local application. Now let's see that code a little bit. So that's appeared in this folder called Node Modules. And if you look in there, you'll see there's a few things in here. There's this giant text file that's like 1 million lines long, and that defines examples of correct spelling. And then there's also an example of how to actually invoke this thing. So here's an example Node.js application. And what it does is it requires a reference to speller, and then it reads that giant text file into memory using read file, and then it trains the speller with that test data. So the speller knows what correct English spellings are. And then after it's been trained, it can run speller.correct, and it can correct single words. So it replaces a single misspelled word with the correct spelling for that word. Which is good, but that's not really what we want to do here. We want to correct entire sentences. So we're going to have to write a little bit of code ourselves to wrap this with something that corrects entire sentences. So I'm going to write a shared script now. This is a cool thing you can do to share logic across multiple server-side scripts. And I'm going to create a shared script called corrector.js. Okay? And I'm going to use the speller module to correct complete sentences. So firstly, let's add a reference to the speller module. So I'm requiring the speller module that I've installed. And the next thing is, I want to correct entire sentences. So here's some logic for doing that. I'm defining a function called correctAll, and the way it works is it goes through the sentence and it uses a regex to replace every word in that sentence with the correct spelling for that word and returns the result. And I want to make this function available to other scripts, so I'm adding it to the exports object, and that's how Node modules work. Right, but remember, I also need to train the speller with the test data. So let's write some code that trains it. So firstly, I'm going to use some standard Node APIs, the standard file system API, to read the contents of this big text file. And then when the data has arrived, I want to train the speller with this data. So let's run the train function on that data. So simply I say speller.train on this chunk of data. And then finally, I want to check that it works. So after it's finished the training process, I'm going to run it on a test sentence. So here's my test sentence, and you can see it's got lots of misspellings in it, and it's going to run correctAll on that sentence, just to check that we can fix all the words there. Now, I can run this code locally, because I've got Node.js installed here. You can install it on Windows just as easily as you can on Mac or Linux. And so let's run it. I'll say node, and then the script is called shared corrector.js. So that runs, and it runs the training algorithm, and then when it's finished training, which it will do very soon, you see I've got the corrected version of that sentence, and all the words in there are now spelled properly. So that's looking pretty good. It would be nice if we could use this script on the server in mobile services. So I'm going to use source control to send all of that script up there. I'm going to say git add everything, okay? And then I'm going to say git commit with a message added speller. And that's going to add all of those files to my local source control repo. Now, of course, you can use a proper graphical Git client to do this, and you don't have to do it in the console. But anyway, I'm using the console, and then I'm going to push it all up to deploy it to my mobile service with git push origin. And that's going to require me to enter my password, so I have to stop talking. And hopefully I've typed it correctly. And that will take a couple of seconds to push because there's a lot of data there, 2.3 megabytes, because of that giant text file. So it's hopefully deployed all of that stuff to the mobile service. And now this custom library, corrector.js, that we just wrote locally should be available in the mobile service. So let's have a go at using it. I want to use it whenever somebody inserts a new to-do item. I want to fix their spelling. So I'll go to the insert script for that. And I'm going to use the corrector module. So let's just drop in usage of that. So what I'm doing here is I'm requiring this corrector module from the shared folder, and then I'm correcting all of the text that's been entered and replacing the text that the user entered. And if you're wondering why I've got require underscore instead of just require, that's because this source control feature is currently in preview and it's not fully released, and there's a bit of an issue like you've just seen earlier, and I'm working around it with this weird version of require. But hopefully, like I said, that's going to be fixed really soon and you won't see this issue yourself. So you can just pretend that that's just a normal require statement. So I'm saving that script now. Now let's see if it actually works, shall we? Because it would be pretty cool if it did. Firstly, let's just test I didn't break it. So I'll just enter a random word and see if it's still alive. OK, it's still alive. Very good. Now let's enter some really badly spelled stuff. Let's just get rid of some of the stuff. I'll get rid of that and that. And I will put my same spelling mistakes in. Please, now let's do that lower. Please correct all test spelling. And I'll hit go on that. And then hopefully we'll see the correctly spelled phrase appear below. And I can do all kinds of other stuff like remember to purchase dictionary. And then when that works, you'll see we get the correctly spelled thing. So excellent. We've implemented our own autocorrect that no doubt has all kinds of hilarious consequences when it guesses the incorrect words that someone wanted to type. So there we go. We've been able to use a custom third-party NPM module, which adds an enormous amount of power to your application for reusing source code. So let's summarize what you've seen. You may have seen this slide from my talk yesterday. Mobile Services has a range of features that are designed to gently take you up a power curve. So at the beginning, the most basic feature that you've seen over and over is the ability to store data in your mobile service. That's kind of central to everything. And then it's very important, of course, that you can do authentication and authorization. We support those 4 different standard providers, and you can roll your own. And in addition to just being able to force people to log in, you can write your own custom logic in JavaScript that runs when people perform table operations. You can also write custom logic that runs just whenever somebody sends an arbitrary HTTP request. That's the custom API. And you can send native push notifications to Android, iOS, and Windows devices. And for web applications, if you saw my talk yesterday, I showed a way of doing that. And if you didn't, you can get the video that shows how to do WebSockets. Then you also saw how it's possible to run custom logic at arbitrary times with scheduled jobs, which is very convenient. And then we went into the really powerful stuff, such as using source control and being able to write code locally, and then finally being able to pull in third-party standard NPM modules and do whatever it is that you want, including fairly powerful stuff. You're not limited to just doing spell checking there. You can also do stuff like, let's say you want to store your data in a Mongo database instead of SQL Azure. Well, you can bring in the Mongo client library through NPM and then start calling that from your custom script. So there's tons of stuff you can do with that there. So that is all I want to cover in this talk. There are other resources that you can find, should you wish. The one thing that's really important is that you fill out your evaluations, because this determines whether or not I get allowed to come back and speak next year. So please go and fill out your evaluation and let us know what was good or not so good about this talk. And then I hope you enjoy the rest of your day. I'm going to be at the front if you want to ask any questions, but otherwise I'll let you go off to your next session. So thank you very much.